this computer. I'm sharing. My mic is on. Everybody's happy. Okay. We've been continuing to consider things in Unity. I think we ended class. I left an error on here. So last time we were talking about the idea of these mono behavior scripts, how this is that inheritance model. We followed it. We saw that a mono behavior is actually a behavior, which is actually a component, which is actually a game object. You know, we followed his lineage, but somewhere in his lineage, he's a game object. So game objects are similar to objects in Unity. And Unity uses the C# language as a generic language. So you still have C# there. So in the C# world, the top level object is still object. So game object is not actually the top. Game object is the top on the Unity side of things, but a game object would inherit from maybe perhaps other things, but somewhere object. Because game object is a class in C#. Therefore, it must inherit from something above him, and at some level, it would be the C# instance of object, just like any other language. So using C# in this context doesn't really give us anything, doesn't take anything away from what the C# language can do. But the unityness of C# is really, for C# for us, is delivered by the generic stuff that's already in Unity engine. So that's why when you create a mono behavior, it automatically brings in that namespace. So you have all the Unity stuff available to you. And then there's other Unity, namespaces that exist that let you do more advanced things in Unity rather than here's the core stuff. But like things in Unity you might use often as like rigid body. Well, if you had to import a whole bunch of libraries just to get rigid body to work, that would be not a great thing. Yet you pretty much always are going to use a rigid body somewhere in your game. That guy lives inside of Unity engine, for example. All right, so we saw last time that a mono behavior, which is a behavior, which is a component. Now, if we go back here to Unity, we see over here on the side, if I click on one of my dudes, is this thing still running? No, it's not running. All right, so if I click on, let's just click this guy. So I selected my player. We notice over here that, we have our inspector. There's a whole bunch of stuff in our inspectors, and our inspector is filled up with things that are components. Okay, so we add components to game objects. So that means the idea of something hanging on to a game object to give it some abilities is a component at some level. And one of the things we can do, I can even show you here in code, is let me just comment these things out real quick for the errors to go away. So one of the things you could do is you can say this dot get components. You see these different guys here? Get components. So remind me, what does those angle brackets thing mean again? The greater than or less than greater than deals? What does that guy let me do? Go ahead. We saw it as a hash map as well as an array list before. We saw these being used for those, but that's not what these are. So, but that gives you a pretty far hint down the path. So why did we use these angle brackets with array map? Why did we use it with a hash map? Mostly array list, rather, is probably the one to focus in on. It's generics. So those angle brackets, whenever we see those guys, we're dealing with generics. That allows us to say, hey, if I'm going to get the components out of something, what if I want to get the component that is a rigid body? So we could actually say get component. And I think you did this in your assignment. So if I want to say rigid body RB is equal to this dot, this dot get component, and I say rigid body, that will now get me the rigid body version of that component. So this is saying this, and who is this? This is an instance of mono behavior, right? So this is how an object refers to itself from within itself, and we are a mono behavior here. All right, so myself is an instance of mono behavior. So when I say this dot, I'm saying, self, go get one of your components. Which component? Your rigid body. Now you can only have one rigid body on a game object. All right, you can't have, I mean, once he has a rigid body, he doesn't get to have a second rigid body. He is now a physical thing. He can't be an extra physical thing. All right. So when we say get component and then in brackets say rigid body, it's going to return for us the version of component. So the generic component that is the rigid body. But because we've done it like this, it will hand it to us as a rigid body. If we don't do it this way, we would have to then typecast it to rigid body. And we would do something like get component. We have a thing where I can search by string. I really don't. So what I'd have to do instead is I'd have to do here. Let me just put that back. So I can either do this, and using generics, I would get the rigid body out of this. I wouldn't have to typecast it. Otherwise, I can say component C and then say for. Actually, I could have done this in a for loop. So I can say for component C in this dot get components. I think this is the format for loop. All right, so I'm going to have to get it still as this guy. Is it in? Is it for each? Ha! Got it. That's how you do a for each loop in this language. You got to cycle through the possible options. It's either for or for each. It's either colon or the word in. You're always going to say for each of this kind of thing in this kind of collection. So the thing on the left here is giving me an entire collection of this is all the components that are hanging off of this particular game object. Go ahead.
So calling rigid body TB, are we basically asking ourselves to go get the rigid body component?
TB is not ourself. TB is a variable of type rigid body. Our self is this, which is an instance of mono behavior. So we're saying myself, which is an instance of mono behavior, which is and so this is an instance of mono behavior, which is a behavior, which is a component, which is a game object. So in a roundabout way, this dot get component sort of kind of makes sense because we can sort of say we're an instance of game object asking for our components, even though we were a mono behavior, we're really a mono behavior. If I were writing this, I like to say this dot get game object dot like that. So this lets me say mono behavior, get me the game object that you are attached to. That makes more sense for how, that makes the logical sense for this. When you just say this dot get component, even though technically it works because of the lineage of a mono behavior, it's kind I would call these things like syntactic sugar. It lets you take a little tiny shortcut in the text, not having to write the extra word game object in there. But I think for someone who doesn't understand kind of this nuanced thing that's going on there, where just everything in Unity is a game object at some level, so you can just kind of treat everything as a game object, so you get all the game object stuff automatically, including game objects get component. But when you call that get component method, so when I say this dot game object versus, let me take the same line here. Call this guy TB2, and I'll take out the game object. So this is the version that I do not like. This the second one. All right. But let's think about what's actually happening, because it's easy to look at these two things and say, oh, these are exactly equivalents. The result of both of these lines is equivalent. But what's actually accomplished is a little bit different. So can anybody tell me what is the difference between these two in terms of what's actually getting called, or how the process is working? Go ahead.
Isn't one point directed to the component and the other is kind of one step behind almost?
Well,
Like meaning like it's pointing directly at it, it'll take you directly to it versus like, I'm trying to think of what you explained to us, but it's like it's directly pointing to it rather than like pointing somewhere in the area to it.
Mhm.
And the compiler or whatever has to find it from there.
Right. So I think you're saying this. So for this first line, the one that's on line 10, when we say this dot game object, we are saying mono behavior, get me the game object that you're attached to. Okay. Now remember, it is game objects that hold collections of components. Make sense? We see it, right? When we go out here, we can visually see that as a truth. Over here on the inspector, we add components to this guy. So a game object is nothingness, well, a transform, which is a component in and of itself. So a game object automatically comes with one component, a transform, and you can't take that guy off. You don't get the remove button on transform up here at the top. Yeah, he can't even be disabled. Like you are at least that. You're at least the transform. All right. But effectively, a game object is a collection of components that it holds on to. So it has like a little Santa bag filled up with components. So when we call get components, it gets us that bag of components. Now, there was also a get components that we could pass generics to. So that would give us all of the components that are from a certain type. Now, well, what does that mean? Well, what if you have more than one of a certain kind of thing, like more than one collider on something, or more than one material for, maybe you have a complex game object that has multiple body parts or something like that. Whatever it is, you might have more than one of some components that allow you to have more than one of those components. So if I said, hey, give me all of your materials, you would put materials in the square brackets. It would only bring back your collection of materials. But now realistically, if you're using this format or this syntax, you are probably talking about, hey, go ahead and just give me everything you got and I'll sift through it. Right? That's what the well, here, this is fine. So that's if you're getting all the components. I think I meant to do all components here, but this is fine. This will work fine. All right, so that first one says this dot game object. That is the game object that has the components. Remember, game objects are the children. Game object is the, what is it? It's mono behavior component game object. So great grandfather, right? Great grandfather of our mono behavior class. So we're specifically saying great grandfather, call your get component, because that's the level. That's the guy that has the components. The game object is the dude who gave the componentness to all of the guys after him. All right. And get components is already a set thing. Like we probably, like you can't really improve upon the idea of hand me all the components, right? He's not doing like 11 different steps. He's doing one thing. It's like, yeah, I have a bucket of components over here. You want those components? Here. All right. So it's not like they wrote that in game object for get components, and then they made get components a little bit better when it got to the component class. And they made it even a little bit better once it got to the behavior class, and a little bit better once it got to the mono behavior class. Get components was something that was baked into game objects. So it came with the game objectness of our instance of mono behavior. So if I specifically say this dot game object, I am jumping past that lineage. I'm saying mono behavior, I don't want to talk to you. Behavior, I don't want to talk to you. Component, I don't want to talk to you. Let's get to brass tacks. I want to talk to game object. Game object is the guy who has the get component. So I'm going to tell him specifically, give me your get component. What happens otherwise? If I just say this dot get component, how does that work differently than what I just described? Good.
Is it slow? For your having like access all the different points?
Okay, well, I think it's true. It is slower. What do you mean by access? How does that play out?
Like, when you say this dot get complete, it has to go like that first, I guess, part of the lineage, and then it realizes I can't get to here, so I have to move up and then
Yep.
say I can't get here.
So who is the first person? When I say this dot get component, who is the first guy I'm checking with? Mono behavior. All right, say mono behavior. Do you have a function called get component? Mono behavior is going to say, nope. So what do we do then? Just give up, return an error, say, yeah, we don't have get components. We don't have a get component. No, it checks the next guy. So who's the next guy? Yells up to dad. It's like, Pops, do you have a get component? So that's transferred control from mono behavior to behavior. Okay, so now we got to our instance of behavior. So that relative to, how do we reference the parent of an instance of a class? So mono behavior refers to himself by saying this. How does he refer to his parent, which is a behavior? Super. Okay, super is our parent. So we could try to directly say super.getComponent and just see, that's our individual check. Dad, do you have this? Depending on how it's written, you could say super.getComponent, you know, kind of chain them together. But if we're just using the normal, the way this goes down to variable scope and how variables and methods are resolved. So this is back to an early skill set in coding one. So we're saying this, which is a mono behavior, get your component. Mono behavior checks locally. Do I have get component? I don't. Well, I'm not going to give up yet. I'm going to hold out hope that this programmer knew what he was doing. So I'm going to now check with my parent. We're going to pass the buck and say, okay, I can't fulfill this request. You throw the request up to the next in command, run it up the flagpole. So next guy behavior is going to say, well, do I have a get component? Nope. So he's going to throw it up the command line. And the next guy is going to say, is going to be component. He's going to say, well, do I have get component? Nope. He's going to throw it up the command line. And then we get to game object, and game object, we say, do you have get component? And game objects will say, yes, I do have get component. Now, if he didn't, we probably would have gone up to object, right? An object would have said, I'm just presuming that there's nothing between game object and object, but there's possibly a layer, a transition layer or something that's in there. I'm also technically not positive that mono behavior, and component don't technically implement their own more local version of get component for some reason. We could check, but let's, I mean, but what, yeah, let's just do it. Because I mean, this is as we're trying to answer this, let's try to get it right here. So we're going to say unity mono behavior. It's the British one, right? That guy. And did I make it bigger? Oh, I was hitting my volume. All right. So let's look at the lineage here. So this guy inherits from behavior. Let's look at his methods. All right, so here are his public methods. So we're going to walk this lineage here. So we're starting at mono behavior. We see that his parent is behavior, but before we check his parent, let's just see what is mono behavior bringing to the table. So this is local mono behavior stuff. Mono behavior brings these properties, did awake, did start, run edit mode, blah, blah, blah. So various properties to do various things. We have some public methods, none of which are get component. We actually have a static method. And what does it mean for a method to be static versus non-static? Remind me, I've forgotten. Static doesn't require an instance of the class. I feel like you might be answering what is a singleton. Go ahead.
Static class.
Yeah, you got to use it. So you when you declare a class and you fill it with static members, so either static fields or static methods, is there a such thing as a static constructor?
Yeah.
Oh.
Static, they can't return it.
Well, constructors can't return anything, but static's not the return type. Static is a modifier of a class. You either static or non-static. If you're static, as you said, that means you are owned by the class itself. If you're non-static, that means you're owned by an instance of the class. If you want to use something that's non-static, doesn't have the word static in front of it, you have to first create an instance of that class in order to use those things. Otherwise, if it's static, you don't, not only do you not have to create an instance, you shouldn't create an instance. You access it by calling it with the class name itself. You don't define it with the class name. You just define it with static in front of it. Then when you call it, you use the class name to call the static members of that. But can constructors be static? When do you call a constructor? What always immediately precedes a constructor?
It's like what's after.
Well, no, what's right before? So if I had a constructor for I was creating an instance of the random class. So the constructor's name would be random, right? What comes right to the left of me calling the constructor for random? If I were to write in my code here, I was starting to I was saying random r is equal to something random new. So we're missing the new keyword here. All right. Do you see it's can you tell me why it's giving me the red underscore here for random? Why is he yelling at me?
Class.
Random lives in a different library. Um, but that's okay. The syntax here works. So this is a constructor. Constructors are always preceded by the new keyword. So constructors, it doesn't make sense for there to be a static versus non-static. There isn't a decision about, well, do I have to make an instance first or do I just use the class? This is where instances come from. This is how babies are born or something like that. This is where instances come from. So it would never make sense for a constructor to have be static or non-static, just like it doesn't make sense for a constructor to have a return type. constructor's return type is always a memory address because it's always using the new keyword, which goes and gets us memory addresses, right? All right, so in any case, back here, we're still looking at mono behavior. We see that his parent is behavior, so we have a way of going and checking him in a second. We see that none of his public methods are the get component. Static method means that you can say mono behavior.print, and that writes stuff out to the console. Um, uh, yeah, whatever. Then we have a whole bunch of messages. We haven't talked about that yet, but we have this idea of listening for messages. Did you do that anything in the tutorial? Were there message listening stuff? Or do you not know what I'm talking about? Okay. So we'll get to some examples of this. Actually, didn't you have an on collision? Okay, yeah. So you actually did participate in it. They just didn't say you were part of messages. So if you go back in time, in the early days of this type of mindset and coding, it was called event-driven programming. Okay, so that means effectively your program launches and it's sitting there waiting for something to happen, waiting for an event. And when that event occurs, it then jumps into action and responds to that event. Now, it might have some stuff it's doing automatically in its own thread or backing up stuff, whatever, listening for incoming connections. So, we know at this point that you could have your program doing multiple things at once, right? But, at the very least here, um, uh, it's listening for events to occur, like maybe a button press, so like in when you're writing mobile apps, iPhone, iPad, Android, whatever, one of the things when you have multi-touch screens is you might want to know, well, when did they touch down? When did they touch up? When did they let go of it? When did they touch and hold? Kept it there for longer. It's probably 2 seconds is the default or something like that, some delay. So just kind of think about when you're using a device, what are the various events that you could trigger? Like you have on key press, and when you have on key press, whatever key you pressed might get passed along. So if I come out here, let's just get rid of this guy so the error goes away. If I start typing something down here and I say on, let's see, isn't it on key pressed? Or is it input? Input dot on. Let's just say key pressed. We'll browse. All right, so most of these guys start with on. So that is the event. On some event, when this event occurs, we can write a function that these functions are automatically being called. They're participating in something called messages as we go through here. So you can think of messages as basically like methods. It's a built-in method, which means that it automatically comes with it. And if you want something special to happen, you have to override it to make the special thing happen. Similar to what we did with threads in Java, where we created we had our class extend thread. So we got the special thing from thread that came with the start function for threads. And that start function is what we called, but all that guy did is call the run method. But he called it with his Harry Potter wand out, and he said, okay, create thread. It probably had a thread of Loomis or something, one of those things. So, that start function does whatever magical operating system stuff has to occur in order for a thread to come into existence. That's not something we get to do as the programmer. But we can ask the language to go ahead and negotiate with our operating system and give us a thread. And that's what that guy did. But we got to decide as the programmer, what did we want this thread to accomplish when his start function gets called? We wrote that inside that run method. And if we didn't put anything in our own version of run, the thread didn't do anything. It went into its run function that has nothing in it and hit the end of its run function. Thread is now complete. Thank you for wasting everyone's time. is the idea there. So usually if you're creating something that is a child of a thread, it's with the intention that you want that thread to do some stuff, right? But you want to do it in a non-blocking way, meaning this is some part of your program that can go off and do its own thing while the program is sitting here and doing something else. Now, the cleanest, can anybody give me a good example of a program where you might want to do that? That happens almost constantly, that you're exposed to on a daily basis? Give me more.
Like two string, like you override it if you want it to, instead of like object variables or they're called, then you can pretty much change it to something else.
Okay. But we're talking specifically threads. When's an example? So we're not talking about when will you override. We're talking about what's a common example where a thread is the right tool for the job? And it's something that you run into all the time. How many of you use programs that talk to things that more than one person uses at the same time? For instance, how many of you have used Google recently, or ChatGPT recently, or Boodlebox, whatever? You type stuff into a box and you press enter. Well, that prompt goes somewhere. So if you want to think about this like like it's going to some sort of a phone call switching center, the phone rings. Now, when you talk to ChatGPT or Google, are you the one client they're talking to for the duration of your chat session? Or do you feel like you're getting personal service, but you expect if your buddy was sitting next to you, he'd be able to use ChatGPT right then as well, right? So what's happening is the ChatGPT server, I'm probably simplifying it for a big enterprise like that, Google, ChatGPT, because realistically, before you even get to the server, it's probably going to a warehouse and then directing you to one of its server clones that has the most resources currently available. But we could just treat that warehouse as one gigantic super resource computer. All right. So when you get to that computer and the Google people pick up the phone, they don't keep you on the line right then and there, blocking everyone else from getting them. What they do is they spin up a thread, they hand the thread the phone, and the thread runs off and manages the communication between you and what the thread has access to. That way, the dude whose job it is to answer the phone can go back and wait for the phone to ring. So the next person can come in and use ChatGPT or whatever. So this is a perfect example of multi-threading that's happening on the server side. So the ChatGPT or the Google people or whatever, when you hit their server, they have to say, oh, I have another guy waiting in line right behind him in a nanosecond. So I'm going to spin off a thread and throw him over there. In fact, usually companies like that need to have, they have a lot of traffic. So there's people hitting it many, many, many times per second. They'll create, how many of you have heard of something called a thread pool or seen those words somewhere written? Technology, we see a lot of words and phrases. We don't have a clue what they mean, right? Have we seen thread pool somewhere before? So thread pool basically says, okay, well, rather than taking the time to spin up threads as needed, what we're going to do is we're going to keep a bucket over here of spun up threads. So as the original server is launching, it's going to go ahead and just spawn off 200 threads. Like we're going to keep you in a bucket. You're going to sit there and you're going to wait till I tell you to turn on. All right, but they're already alive. They're ready to go. So all you're going to do is you're going to let the thread has been created. We just haven't created the start function. And all we're going to do is we're going to probably use a setter. We're going to set that thread's information that he needs from that incoming call to the value and then tell him to start. We didn't have to wait for that thread to spin up. Because as you imagine, if the language is having to negotiate with the operating system and say, hey, I need a thread. Threads are something that are built into the underlying operating system. It's a service the operating system provides, is multi-threading. If you go back especially if you're dealing with the Linux world, and you look at the different threads, if you're dealing with older software, you have to look at which kind of threads do they use. If they use too old of thread types, like we have multiple versions of things called like P threads, well, you might have to install an older library that speaks the old thread protocol. What is protocol? When we hear protocol and we're looking at something, it scares us, but what is that? What is a synonym for protocol? Language. Right now, I am speaking the English protocol. All right, so, your computers have tons and tons and tons of protocols as well. They are far, far simpler than English. Most protocols say, hey, here's the 8 things I can do. And this is how you ask me to do one of those 8 things. That's the entire language. And we call it protocol, and then it immediately intimidates us. When it's like, look, here we have 8 buttons. It's like the McDonald's order thing. Because isn't that what they did for years? They had the McDonald's screen that had the pictures on it. When I was a kid, they didn't have the picture one. They had actually, I want to say they didn't even have the computer screen thing. They still had the thing that had the ringing, the paper. But let's just say reasonably modern McDonald's, they had to key in, make change, stuff like that. Well, young people say can't make change. Well, and it's not that they're stupid, it's just they haven't grown up doing it. Apple Pay. Change happens automatically. You're not used to dealing with these chunks of metal that are sitting in the dirty drawers, right? It's not part of your daily life. But in any case, now if you look at the McDonald's screens, they're just punching like the picture of the Big Mac. That's what they want, is the picture of the Big Mac. And then when you take things away, you're like putting pictures of pickles and stuff like that. They don't even make them read. But now all they did is they turned around the screens, and now you can order your own stuff. You run into these McDonald's now where they have like 1 or 2 employees in the entire McDonald's, and they're all in the back cooking. And they just refill the ice in the soda machine, or you do all the ordering. The stuff comes out on a conveyor belt, or maybe the one person brings out the tray. Man, that's how McDonald's should be. They never mess up your order. Well, isn't that the joke? That you're in an authentic McDonald's if their ice cream machine is broken or the shake machine is down. Like they have like really good chocolate shakes at McDonald's, but I don't think there's any aspect of that is like made of milk, or I mean that is like shake product and that they just make cold. That's one of those things like, okay, this tastes good. It's probably going to kill me, but so is the 11 other things I've put in my body today. So you just like roll the dice. See, this guy gets it. Oh, Shamrock Shake. Wait, does the Shamrock Shake, do they have chocolate in that? Or is it just the mint? Okay. Because my wife used to get the Shamrock Shakes all the time, but she hasn't gotten it in several years since she was diagnosed, and she can't have chocolate now. So I wonder if it has cocoa in it or something. They have it like this time of year, I think usually. And it's I think it's supposed to be like a mint flavored shake, or maybe it's a mint chocolate chip type of flavor, but it's green in color, but it is good. It's like a subtle mintiness. Well, my wife used to like it, but she hasn't, or now she's into peanut butter shakes from Five Guys. Yeah, that's a $12 DoorDash is what that is. Well, Portillo's is my favorite restaurant. Our grad students, they a lot of times come up from Chicago, and when we're going back to having our evening classes again now starting next year, but when they would come in for the evening, they're all the Indian students are always running late. Well, they bring in a bag of Portillo's. Sometimes tardiness is acceptable. And I had my order. I had the Maxwell Street Polish, big beef, Italian beef, double dipped, chocolate cake piece. Chocolate cake shake, I think, is overrated. The idea is cool. You have to have it at least once, but after that, you might as well just get a shake and get the chocolate cake, and you do you from there. Otherwise, it's not drinkable. Even with that giant straw they give you, you can't drink that. His spoon. Well, now it's not a shake. That's a blizzard or or McFlurry, whatever the other guys have to change the name to. All right. So sometimes if you want to be lazy, you don't want to look up the documentation. Although getting used to reading the documentation is an important skill. You've heard me say that for a long time, right? Now you're seeing us do it. But whenever you're dealing with things that, in this case, this is a mono behavior, the various messages you can choose to respond to. These are all the different things that can happen related to a mono behavior. We can have on animator move, on application focus, on application pause. These are all opportunities for you to interject something. So for instance, as the application is being paused, whatever that means for your application, you have a moment there where you can write some code and interject as it's going into sleep mode or pause mode or whatever. So all these on things, what it is listen for the alarm. When the alarm for that warning goes off, you get to do something before it finishes pausing or something like that. On became visible, invisible, blah, blah, blah. On collision enter, this allows you to programmatically. So remember, we talked about collisions and triggers. What's the difference between a collision and a trigger? Go ahead.
Collide into each other, and then triggers is when something happens, and then as a result of that one thing happening, something else happens.
What kind of thing happens?
Like if A goes up, then B will come down. Versus a collision being if A and B collide into each other, or if they hit each other in both.
Okay. You are.
I don't technically understand, but I remember you talked about if like a character enters a room and crosses the threshold, then a part of the map might eliminate. That would be a trigger, whereas a collision would be balls hitting each other. So it's looking at two objects as opposed to like one moving object, one fixed thing.
Okay. Go ahead.
One has a rigid body and one does.
Well, any kind of well, actually, a collision requires a rigid body. Actually, yeah, it does because you need gravity. Collision requires actually they both require a rigid body in order for the underlying thing to occur. Go ahead. Oh, that's so. Yeah. So ultimately, they're both the same thing. A collision has occurred. Two game objects have intersected each other among their collider boxes, right? You know, we've seen mesh colliders that are on our objects. Various objects have like a box has a box collider and things. So there's certain specialty colliders, sphere collider and things like that. But then you have the catch-all mesh collider for strange shaped things, or if you do a 3D model of, you know, some Pokemon or something like that, that, you know, he's not shaped like a box or a sphere. He's got, curves and points and, and a tail and stuff like that. You can use a mesh collider to accomplish collisions at all points around that 3D model. Keeping in mind that sounds like it's probably using more horsepower than a box collider. And it is, but computers have quite a bit of power and stuff. The difference between a collision and a trigger, though, is whether or not physics has an impact on that thing. So the rigid body is pretty close to that, where if you want physics to even have a chance of having an impact, you got to have a rigid body, because that's the only way you can get mass and have physics operate on the world around you. But a trigger says, okay, we're going to allow you to become aware that two things have overlapped. You get to programmatically handle this if you want, like you said, like turn a light on. So maybe if you're walking into a room and you kind of hit a point when the lights should kind of automatically come on, kind of like some of these classrooms where you walk in and once you're far enough into the room, there was some motion detection thing that figured out you were there and the lights just came on. You triggered the lights. It wasn't like you got hit by some force field and thrown across the room. Oh, that would be awesome. But so triggers let you programmatically handle it. Collisions allow you to have the physics engine handle it. So what do you think on collision enter is for? If collisions let the physics engine handle how these things are bumping off each other, what do you think we would use on collision enter for? Well, you gave me an example of when to use a trigger, right? So we do have a on trigger enter. So there's the competition. Okay, so we have an on trigger enter, we have an on collision enter. I'm pretty sure you used on trigger enter on your game to handle the when your guy picked up the things. Because when you were driving around, it's not like you hit that diamond spinny thing and it's not like he flew across the room, right? You intersected with him and then you, I think, probably updated some counter for, hey, you collected another dude and then you destroyed the game object. I think last time I talked about you can, if you're going to reset like the chessboard, let's say you're making a chess game and you don't actually want to, when somebody, takes a pawn, you don't want the pawn to literally destroy out of existence. If you were playing a real chess game, you just take it off the board, set it to the side, because when you restart the game, you're just bringing all the pieces back together, right? So when somebody takes the pawn, if you want to make things look clean, you can make it invisible and then put it to the side of the screen. Or what I like to do is I like to remember the initial spots for everything. And we've done that. I think I showed you an example of that with an empty game object. So I'll have empty game objects for where each thing should live. And then I'll have a script that lets you attach that to it. So then what I'll do is I'll make things invisible. I'll just throw them 100 feet in the air. So they're off camera. You don't see them anymore. And then you keep playing your game. And then when you're ready to reset, you just make every single one of those objects go back to its home. And now the board's reset. But you didn't have to recreate those game objects because you never decreated them. You never destroyed them. You just made them invisible and took them off camera. All right. So these are like little things that you might do on like an on trigger enter. Because you don't need your pawn to go flying off somewhere or whatever. That's not part of what, well, except if it's wizard's chess, right? That's they play wizard's chess in Harry Potter, right? Yeah. When does that show start? There's like this new Harry Potter TV show coming out where I guess each season is one of the books. It's soon.
Number 20.
I'm very torn. They've done something in the show that I really don't like. They made Snape black.
Oh, yeah.
I mean, there's nothing wrong with a black actor, but Snape specifically in the book is described as a pale skin, is described as a white guy. It's just, it is what it. So you've now broken the book. There's plenty of other black actors you could put in the show that make perfect sense with the book. But why Snape? He's a major character.
You have to do an Alan Rickman look-alike. That's literally on.
Well, I don't disagree with that. Rickman played that role great. Just like, can you really replace Deadpool? When Ryan Reynolds is gone, how do you remake Deadpool?
Red.
Like, well,
Oh,
What?
so an example for on collision activity. If, for example, you played Hello Neighbor, where, okay, bear with me, but in Hello Neighbor, you have this like kid, I guess, who's trying to break into his neighbor's house. And when his neighbor like touches him or something, he pretty much like resets back to his home, loses all his resources that he gained from snooping in his neighbor's yard or whatever. Would that be an example of an on collision too?
Well, when he touches something, does physics occur? Does he blow back or anything? Or does a bunch of stuff happen? He just resets to the beginning.
He doesn't blow back at all.
Yeah, so it would be a trigger then.
Okay.
Yeah, because I mean, you would programmatically handle all your resources reset. You're starting over, starting to level over. So you programmatically do that. But since you're not relying on any sort of physics or that kind of stuff, yeah, that wouldn't use on collision enter.
Would it be like the car in like the race car game or whatever, and as soon as you knock the car over, you get a point, that would be considered an on collision entry.
Well, it's not so much what's considered an on-collision enter. It's when would you be interested in responding to this message? So imagine like a car crash, and then all of a sudden you had, the game engine, the world that the car is driving in, just scream, two cars just crashed, in case you're interested. And then if you were interested, you could have some code that occurs when those two cars crash into each other. All right. So that's what these messages are for. So anything that says on in front of it is usually here's a message. You decide if you're interested in doing anything about this. So the question I'm asking here is when might you be interested in doing something about on collision enter, about a collision beginning, when we've learned that collisions allow the physics engine to do all the work, the things bounce off each other and stuff like that. During a car crash, or insert your favorite horrific accident, yes, physics is involved, right? You saw that the plane that hit the fire truck, whatever, this last week on the runway, and the pilots were ejected. So physics clearly happened, right? But do other things also occur? So you've perhaps your wallet is has fallen onto the floor or something like that. So now you no longer have access to that resource. That resource is out of reach. Okay, so let's assume that you have, your set of resources that your character has, and now some of those resources, as a result of the physicality of the impact you just had, some of those resources are no longer available. You need to be able to programmatically mark them as unavailable, for example. So on collision enter says, well, what if I want to do some programming stuff as well as have the things smash against each other and have physics do its thing? So you get all the benefits of the on trigger enter. You get to programmatically do stuff related to the collision. But now you say, well, on collision enter says, I'm already relying on the physics thing. He's going to do whatever he's going to do, but I need to do some coding stuff behind the scene as related to this as well. So it kind of gets you the best of both worlds. So one of these isn't necessarily better or worse than the other, a trigger versus a collision. It's what's the right tool for the job, triggering lights as you walk into a room. Go ahead.
So on collision enter would be two balls hit each other and bounce off. On trigger enter would be two balls hit each other, bounce off. No.
A collision would have two balls bouncing, rolling into each other and bouncing off. If you are interested in programmatically doing something as a result of them banging into each other, as well as them bouncing off, you would say on collision enter.
Got it.
If you wanted them not to physically interact with each other, so they bumped into each other, but there wasn't a physical reaction, they just rolled right through each other or something like that, but you still wanted to also programmatically do something, you can choose to implement on trigger enter and say, oh, something just happened. I need to programmatically do this. Maybe you destroy the game object, which is like what you did in the tutorial when your guy collided with one of the little diamond things. On trigger entered occurred because you set that collision up as a trigger,
Okay.
which says turn off physics. I don't want these guys to auto bump into each other, but I'm going to programmatically handle it. You just went and did a destroy or however they had you implement that in the tutorial. You said this game object needs to go away. He doesn't fly across the room, but he's also not there anymore. And you chose to add one to your score. So you also incremented a counter as your code. So your code for that guy would have been this dot. Actually, it's just destroy, right? Destroy this dot game object. So that's how you got rid of the dude. And then you probably said this dot count plus plus or whatever. Coroutines are how you spawn off threads inside of your code, by the way, since we just had that thing pop up. All right, questions on collisions versus triggers and these callback functions in newer languages. So for instance, anybody who's worked with like JavaScript. JavaScript uses callback functions when you do what are called asynchronous. Who's worked with JavaScript in here before? Okay. Have you done something with like something called an async call? ASYN, ASYNC, async call. What is that? What does async call do? Just looks cool. Totally looks cool. Well, what word do you think async is short for? Asynchronous. Well, what does asynchronous mean? If you are taking an online class asynchronously versus synchronously, what does that mean to you? Huh? Okay. So an asynchronous class would be a class that doesn't have a regular meeting time, doesn't have a lecture. You have to complete the work. The teacher will grade the work, but you are doing it completely online. You might have due dates, so there might still be order, but it is something that doesn't require you to adhere to a schedule other than due dates for a class, let's say. So asynchronous to us says do something in the background and don't block what I'm working on right now. It's a thread, right? Async spawns off a thread. And usually in your programs, I'm guessing it was when you wrote a program that probably talked to an API, right? And maybe at the time you didn't know what an API was, but you said, hey, I'm going to go call, I need to get a whole bunch of Pokemon stuff, or I need to get stock prices, or I need to get weather forecasts, whatever data you're asking some external entity for, and you're bringing into your program, you're making this API call. You're saying, weather channel, I need some stuff. Now, you don't know, depending on what you're asking for and how much traffic Weather Channel has right now and how, any hiccups your internet's having and things like that, that response could be a second or two, or it could be 30 seconds in an extreme case, let's say, if you're looking for the 5-day forecast or whatever. But it takes time. Well, you don't want your entire program to feel like it locked up. Where the person can no longer scroll and stuff like that while that data is being loaded in. So what does it do? You create an asynchronous, you spawn up a thread, and that guy goes off and he does his thing. But this guy says, when you're done, let me know. And they do that through something called a callback function in a lot of these languages. So when you do an asynchronous function, when you do an async call in JavaScript, you usually would feed it an inline function definition. So you would write a function inside of the parameter for that. So you would say like, async something like this, and then it might say like new lambda, depending on the language, whatever. Lambda expression, then it would have all your code in there and do all this stuff. That's what gets called when your async function finishes. It's called a callback. So when it's done, when it gets all the data and it's ready for you, it'll say, hey, guy who spawned me, I'm done with what the stuff you needed from me. What do you want to do with it? That callback function would take in the result and decide if it's going to populate a table on the web page or whatever it's going to do. But he gets notified when the asynchronous process finishes. So a callback is kind of like these on collision enters, on trigger enters. It's kind of like those types of things. You can see I'm interested in something. I'm going to go ahead and write some code associated with that something so that if it occurs, I can handle it. But also keep in mind that you only get one on trigger enter per class. So let's say we're in a mono behavior associated with our player, and our player is going through the game. Okay, he mentioned that, well, maybe you hit a trigger, and that trigger is what you on trigger enter turns the lights on. You know, you didn't trip up, you didn't fall into the room or something, just you hit a certain point, lights turned on. Okay. Well, is that player also going to maybe bump into other things that are going to be triggers that have, you know, maybe you bump into a trigger and all of a sudden one of those giant guillotines drops down right in front of you. So you better have hit the brakes. You know, that would be bad. Okay, but that's a different trigger, different result. So you might give those triggers names because they are all going to call back the same on trigger enter. So you see how this guy gets what gets passed into on trigger enter is a collider. So a collider is the parent class of a mono behavior that has a collider component associated with it. All right, so so you'll have box colliders, mesh colliders, sphere colliders. The parent of that will be a collider. So whatever kind of collider just got triggered, he's coming in here as other. So we can maybe ask the question, well, if other dot, you know, you can say tag or you can say compare tag. And inside here, you could say light trigger, something like that. So you might do something if it's related to a light trigger, else if other dot compare tag. How do you spell guillotine? Is that it? Sword thingy. There we go. All right. So, you know, so you would inside of your on trigger enter, you would have to have a series of if statements if this particular game object that this mono behavior is attached to might run into a bunch of different types of triggers and you need to handle those triggers differently, right? This is pretty similar to our try catches. So when you have try catches in languages, when would we have a try catch? Why what problem does try catch solve in programming languages?
Some, I know that your program may or may not return the error, and you kind of want to prevent the program from shutting down entirely. You just want to tell the person, hey, it's slow.
Okay. So old school, if you had a bug or you ran into an unstable situation for whatever reason, maybe a file that didn't exist or something in your program would try to open that file. The file wouldn't have existed. It would have then tried to do the next line on a null value. Or if you've seen old C programs that deal with like if you ever copied stuff from a C program, and hopefully you're from our example right here, like if you use async a bunch of times, now you see async actually meant a pretty easy thing, right? But you've used it 4 zillion times, like, well, what's this? Well, it does what I need it to do. You know, but if you get enough of these reps under your belt where you understand these things, you can look at any language. And right from here, you can just say, well, I wonder what I can listen for. You can just put on in here and just look at you know, that's why an IDE is strong. It's for programmers. It'll show you things like this. You don't have to go and look at the documentation necessarily, or you can just kind of, you know, toy around with it and see what these different things will do. You know, but in any case, a try catch is when you have a more modern program where you say, look, when we know that sometimes bad things happen, we know sometimes your internet goes down, and so the connection that you had to the cloud is now cut off. Now, maybe something that your program does before shutdown usually is it stores its current state, something like that, right? So if your program is about to crash in a very unnatural fashion, well, actually, it would be a natural fashion, okay? You know, if your program crashes without you having an opportunity to do anything about it, you've lost that opportunity to back up the state of your application. Whereas if you try to do something that might cause problems, and then you catch one or more of those kinds of problems, maybe it's a on file not found, or usually it's just called file not found exception, right? But you see how I just said it a different way and all of a sudden it sounds just like Unity? Okay, so on file not found, I would kind of like the program not to just die. At the very least, let me back up all my crap before this thing shuts down. Or maybe instead of dying, I give a message to the user and say, hey, file not found. So you just terminate what you were about to try to do. Now the program's still healthy, it's still alive, it didn't crash, but you were able to get it back into a stable state because you worked with a more modern thing called exception handling. And with exception handling, they've introduced the idea of a try and catch. I'm going to try to do stuff that might throw exceptions. Not every class throws exceptions, but many classes throw exceptions. Exceptions come in two flavors: normal exceptions and runtime exceptions. A runtime exception says, hey, we're not going to stop your program, but if you're interested in dealing with this exception, you can write the code to do it, but you don't have to. So a runtime exception you don't have to deal with. But most exceptions, you would have to do a try, put the thing inside of that try that might throw the exception. Now, if you want to be real granular, you would only put the one line in there that might throw the exception. But what most programmers do is they just say, look, I'm going to be messing with stuff. Maybe you're messing with a block of 100 lines of code, and maybe there's 3 different kinds of exceptions that can occur inside of those 100 lines of code. Well, now what you can do is you can say, well, I'm going to try to do these 100 lines of code. Bad stuff can go down in here. Most of the time it doesn't. Most of the time this runs, no problem. But bad things can happen in here. But actually 3 different kinds of bad things can happen in here. So you could do something like, I'm going to do a try to do 100 lines, whatever that was in. Now you could just do a catch exception E like that. And say, oh, sorry, that's not parentheses, that's curlies. Okay, so you can do that. Now, one thing, remember how I said that C# and Java, same language? Well, keep in mind, I'm writing C# code here, even though it looks just like the Java stuff we've written before. All right, go ahead. Same thing. So so this allows me to catch a catch-all exception. So every single exception that is in that's in any of these programming languages has a top level class called exception that it inherits from, right? So this is saying, look, anything that is an exception, I'm going to catch with this one guy here, and I'm going to say console dot write line. Bad stuff. Something like that. See, totally different language. Instead of system.out.println, it's console.writeLine. These things are not even close to each other. So, all right. So, we could just do that. We can say, okay, anything bad that happens in there, we've said that those 100 lines contain 3 different opportunities for bad stuff. But I can say, look, I don't want to be granular about this. All I'm saying is, like, look, if anything bad happens in here and the program is about to croak, what I'm going to do is I'm just going to make sure the program gets backed up, and then I'm going to shut down gracefully. Maybe that's just how you want to handle it. But let's assume that you are in a situation where you maybe want to deal with an IO exception. So now you are specifically dealing with an IO exception in here, bad IO stuff. But now maybe you say, well, if it's any other kind of exception, I'll either do nothing, or here, we'll just, to keep it consistent, we'll say bad random other stuff, whatever, something like that. So now this single try has multiple catches underneath it that it goes through in order. So when an exception occurs, it says, well, was it an IO exception? If yes, if it was specifically that kind of exception, then this line will execute. Now, if it's also a normal exception, we will also hit this line here. So it spills through. Now you actually can get it to stop spilling through by putting a break in there. And you've probably seen something like this in disguise before. In some languages, it's called a switch statement. So you can bail out of this thing by maybe returning from the function you're in or breaking out of this thing. But otherwise, it just kind of think of it as a filter. So the top level here, we're filtering IO exceptions. But any other exceptions that drizzle through are still getting more stuff. But those IO exceptions also drizzle through. We just kind of filtered them first, did something related to just those guys, then let everything filter through so it hit more stuff. If it hits the generic exception, then it's just that catch-all. But the try catches allow us to deal with multiple things here. All right. So on trigger enter, on collision enter, these are things that allow you to respond to global situations, not just things associated with you. So for instance, on trigger enter will get called whenever a trigger is entered related to your game object. It might not be something that you're even going to deal with. You might just say, well, if you're this or this, I'll handle you. Otherwise, I'm just going to ignore it. You must have been an unimportant trigger for me. Maybe it's for my pet to hit that thing or something like that. Or maybe it's only during a fight where that trigger is a thing. All right, questions, comments, concerns, bribes. All right, front row at chapel, you're all invited. What's up? Yeah, input output exception. So it happened with file IO stuff, could happen with anything that's an IO stream. So that would be associated with sockets, files, keyboard, basically anything that can communicate with your computer. Not just keyboard mouse or not just keyboard screen stuff. So